Welcome, everyone. Go ahead and take your seats. We're going to jump right in. I'll be your professor today as we embark on a comprehensive explainer into the absolute marvel that is civil engineering. Oh, and real quick, if you haven't already, I highly recommend flipping on those English subtitles at the bottom of your screen to help with your note-taking. All right, so civil engineering is, without a doubt, one of the most vital disciplines in modern society. Today, we're unpacking exactly how human beings take these abstract, conceptual blueprints and transform them into the durable, massive realities we interact with every single day. Let's get started. Here's a quick look at our syllabus for today's explainer. We'll kick things off with the civil engineering discipline as a whole, move into essential construction materials, and then tackle structural elements and loads. After that, we'll cover some common student errors, wrap up with a final reference summary, and finish with a quick knowledge quiz. All right, Section 1, the civil engineering discipline. Now, a really common misconception is that civil engineering is just, well, one single job. But in reality, it's a macro-level assembly of many highly specialized sectors all working together. Think of it like a giant puzzle. A complete infrastructure system absolutely requires experts from all these distinct branches collaborating just to ensure everything is safe, durable, and sustainable. So let's zoom in on a few of these core branches. First up, we've got structural engineering. You can think of this as the human skeleton. Basically, structural engineers analyze and design the literal bones of a building. By using mechanics and the strength of materials, they make absolutely sure that structures can safely resist all kinds of forces. We're talking about the permanent dead load, which is just the building's own weight, plus the live load of moving people and furniture, and even dynamic external forces like violent winds or earthquakes. Next, we have geotechnical engineering. Now, if structural engineering is the skeleton, geotechnical engineering is basically the feet carrying all of the body's weight. Because think about it, every single structure ever built ultimately transfers its massive load directly into the earth, right? Geotechnical engineers study soil and rock behavior to make sure the ground can actually support the foundation without, sinking or failing catastrophically. Moving right along, we have water resources engineering. I like to think of this as the circulatory system of our societal infrastructure. This branch applies the heavy science of hydrology and hydraulics to literally manage the flow of water. These are the folks designing the dams, managing the reservoirs, and creating those massive supply networks that ensure we actually have sustainable drinking water, irrigation, and crucial flood control. And finally, let's look at transportation engineering. This branch is completely responsible for the arteries of our economy. They're the ones planning, designing, and maintaining the highways, the railways, the airports, and the ports that safely and economically move people and goods all across the globe. Which brings us to Section 2, Essential Construction Materials. Okay, so material properties strictly dictate our structural design choices. Take bricks, for instance. They have exceptionally high compressive strength, which basically means they can handle being pushed or squashed with incredible force, making them absolutely perfect for load-bearing walls, but they're brittle. Structural steel, on the other hand, while it possesses high tensile strength and elasticity, it can be stretched and bent without snapping. That makes it the absolute ideal choice for frames that have to endure the dynamic, shifting forces of something like an earthquake. Now, understanding aggregate properties is absolutely essential when we're mixing concrete. Fine aggregate, like your standard sand, is tiny. It has a high surface area that requires more water, and its main job is to just fill in all those microscopic voids. Coarse aggregate, like crushed stone or gravel, is larger, specifically greater than 4.75 millimeters. It has a lower surface area, and it's what actually provides the brute bulk and compressive strength of the mix. And that brings us to a critical distinction I need you all to permanently memorize. Cement and concrete are not the same thing. I hear this mixed up all the time. To use a simple baking analogy, cement is merely the flour. It's just the fine, powdery binding agent. Concrete is the final, finished, baked cake. It's the composite mix of that cement, plus those fine and coarse aggregates we just talked about, and water. All right, moving to Section 3, Structural Elements and Loads. Understanding the exact load path in a building is crucial. Honestly, I want you to picture a waterfall cascading downward, because gravity dictates that loads absolutely must travel strictly top-down. The load starts at the flat slab you're walking on, flows horizontally to the supporting beams, travels vertically down the columns, spreads right into the foundation, and finally dissipates safely into the soil. To really visualize this waterfall analogy, notice how the flat slabs transfer their weight horizontally to the beams, which act kind of like shelves. Those beams then push the weight directly down into the vertical columns. And those columns, they carry that entire accumulated burden straight down into the foundations, resting directly on the ground. But the waterfall doesn't just magically stop at the ground level, right? It ends securely deep in the earth. When geotechnical engineers reach the foundation step, they have a massive decision to make, and it's based entirely on the soil's safe bearing capacity. If the surface soil is strong, they can just use shallow foundations, like isolated spread footings. But if that topsoil's weak, well, then they've got to use deep foundations, literally driving piles far down into the earth just to reach those stronger, deeper soil layers. This leads us right into Section 4, Common Student Errors. Okay, I want to be very clear here. First, as we discussed earlier, please do not confuse cement with concrete. One is the binder, the other is the finished product. Second, never, and I mean never, assume a foundation type without first investigating the soil bearing capacity. The earth dictates the design, not the architect. And third, a lot of students misunderstand the plinth versus the foundation. Look, the foundation is the substructure buried completely below ground. The plinth is the base structure sitting just above the ground level, explicitly designed to protect the interior from dampness and surface water. Let's wrap things up with Section 5, Final Reference Summary. So, to summarize today's explainer, civil engineering is a highly interdisciplinary field, requiring structural, geotechnical, and a host of other experts to collaborate closely. Second, the specific properties of a material, whether it resists compression like brick or tension like steel, will entirely dictate how and where it is used. Third, the unbreakable rule of the structural load path. It is always a top-down waterfall from slab to beam to column to foundation and finally to soil. And lastly, remember that literally none of this happens without accurate surveying to establish correct land boundaries and elevations before planning even begins. And finally, Section 6, Quick Knowledge Quiz. So, what is the correct sequence of the structural load transfer path in a building? I'll give you a moment here to actively recall that waterfall analogy we just studied. All right, got it? The correct answer is slab to beam to column to foundation to soil. If you got that right, excellent work. You now possess the foundational blueprint of civil engineering. Honestly, the next time you walk into a towering skyscraper or drive across a massive bridge, I challenge you to look past the paint and the glass. I want you to visualize that invisible waterfall of gravity, literally millions of pounds of force being expertly guided through steel and concrete safely down into the earth beneath your feet. Class dismissed, and keep learning.